16B students, here are a couple examples of the disk and washer method. So we have the region bounded by y equal to the square root of x equal to 9, which is a vertical line, and y equal to 0, which is a horizontal line, the x-axis, revolved around the x-axis. And I should really say, right, we're trying to find the volume of the solid obtained by revolving the region around it. It's the pain in the butt to write all that. So we're taking the region bounded by these functions, revolved around the x-axis, and we're asking what's the volume of the resulting solid. And the idea is, if I'm revolving around the x-axis, I'm taking a vertical strip. My strip is always perpendicular to my axis of rotation, and I'm revolving that strip around. And when I take this rectangle and revolve it around the x-axis, I get this disc shape. And the volume of this disc, well, here's the thing. This strip is located at x, where x goes between 0 and 9, right? This is x equal to 9 right here. And this strip has a height of whatever the function is. And it's got a width of dx. So this shape here has a width, or I like to say thickness, of dx. And it's got an area that is pi times the radius squared, where the radius is this height, right? If you look at this here, I'm trying to draw it, right? There's my rectangle that's getting revolved around the axis. So the area of this, the volume of this disk, I should say the area of the disk is pi times the radius, but the radius is this function. So the volume of just this disk, which I guess I should still write in black. So the volume of this disk, just make good black pen, it's okay, is just the area times the thickness. So pi times the square root of x squared dx. And the volume of the total shape. So if you took this, right, and I can draw it here. You don't have to draw it though, but if you did, right, the shape would look like this. Yeah, kind of filled there. Kind of have to draw that dashed. Right, that's your shape. It's the solid looking bowl thing. So then the total volume is just you're adding up all these strips, right? You've got this little disc here. You've got this disc here. You've got all these discs in between. I can't draw it very well. But the total volume is just where we're going to add up, meaning integrate all the discs from 0 to 9 of this same thing. And then we do the math, right? We get the pi comes out. Square root of x squared is just x from 0 to 9 dx. You anti-differentiate x, you get x squared over 2 from 0 to 9. You plug in 9, you get 81 over 2 times pi. You plug in 0, you get 0. So there's your answer. On the other side, we can also revolve this region around the y-axis. If we go around the y-axis, then we're going to have to use the washer method, because unlike our previous example, right here the region is flush with or right against the axis of rotation. In this other example, if we're taking the same region around the y-axis, it's no longer flush with the axis of rotation, right? There's some separation between this horizontal strip I've drawn and the actual axis. Also, just as a reminder, since I'm going around this y-axis, my strip has to be horizontal so that it is perpendicular to my axis of rotation. So to find the volume of this washer, well again, just like for the volume of this, the volume of the washer is just the area times the thickness, where the thickness is now, instead of dx, it's dy. Now the area of the shape is the area of the big circle minus the area of the little circle. So I like to write that as pi times big R squared minus pi times little r squared, where, sorry, I dropped the pens. I know my washer looks kind of crappy, I'm sorry. So this would be the big radius, and that would be the little radius. So the big radius is just 9. The little radius is this here. It's my function minus 0. But it's not, so I want to point out, it's not the square root of x minus 0. Because this function is no longer a function of x, it's a function of y. And this actually becomes x equal to y squared. Right? It's not root x minus 0 because this is not y equals 0. This line is x equals 0. So it's got to be x equals y squared for this point minus x equals 0 to get this distance. So the radius isn't this. It's y squared minus 0. Also, we know it's going to have to be in y in terms of y because we have a dy, meaning we're going to have to integrate with respect to y. So to set this up, so my volume of my washer, which I'm trying to write in black. So the volume of the washer is pi times big R squared minus pi times little r squared, which is just y squared, all that times dy. And then usually we always factor out the pi. So the total volume is going to be factor out the pi. The integral, we're going to add up all the washers from way down here, right, where the washer is like this big old thing. Right, I didn't myself from over here. All the way up to way up here where it's this really, really wide but not very big, right? Like, woo, kind of crazy looking shape like that. Sorry, I just ruined my picture. So we're going from as low as y equals 0 to as high as, well, if x equals 9, y is going to be 3 because y is the square root of x. And then we're doing 9 squared minus y squared. And again, right, I already factored out the pi. This is going to look like pi times the integral from 0 to 3. I don't need these brackets here. It's dumb. Of 81 minus y to the 4th dy. And then we integrate, we get 81y minus y to the 5th over 5 from 0 to 3. Oh, sorry, don't forget the pi. It's easy to accidentally leave out that pi. And then you get pi times 81 times 3 is 243. And 3 to the 5th is also 243. Minus 0 minus 0. So we end up with 243 minus 243 fifths, which is, I don't know, it's something. It's, fine. Right, 243 times 5 over 5 is going to be, let's see, 243 times 5 is 1,215. So this is going to be 1215 minus 243 over 5 times pi, which is going to be, sorry, brain. 28, 72, 972 over 5 times pi. The numbers aren't so important here. The process is what's really important. All right.